Hi, my dear students. I am Professor P.V. Rama, Department of Mechanical Engineering. I am going to take the subject on modern manufacturing process. That modern manufacturing process or advanced machining technology means that we are using some latest machining process. Previously, the process we adopted like conventional machining process like turning, drilling, milling, etc. are not enough or not capable of meeting the demands of new technology, that is machining of HST or alloys, means high strength temperature resistant alloys, which are very hard, which are used very much nowadays in rocket technology, space technology, and so on and so forth. So, the process, conventional process are not suitable, and they have got certain limitations like the required accuracy, surface finish, productivity, and at automation. They are difficult to achieve using the conventional manufacturing process. Therefore, the development of unconventional process has arisen. In the conventional process, we use edge tools, whereas in the unconventional process, we don't use edge tools, but we use energy. Energy is responsible. Different types of energies are used for removing the material. For example, thermal energy, electrothermal energy, mechanical energy, chemical, electrochemical energies. So, various processes have been developed, and these are classified according to the source of energy. So, these processes are called modern machining process. I just gave you a bit introduction about modern machining process. Now, let us see one by one. Under mechanical energy based process, we have got abrasive jet machining, ultrasonic machining, water jet machining, where the mechanical energy is used to remove the material from the workpiece. Whereas in electrothermal energy, the processes are like EDM, electro discharge machining, wire EDM, plasma arc machining, laser beam machining, right, electron beam machining, and so on. Under chemical and electrochemical energy based process, we have got chemical machining, electrochemical machining, and recently we have got some hybrid process wherein two processes are combined to take advantage of both the process. Grinding is a mechanical process and electrochemical machining is latest process, and combining these two, we have got electrochemical grinding. We get the benefits from both the process. Grinding will give high accuracy and finish, and electrochemical machining will give you burr free and stress free process. So, combining these two advantages, we got electrochemical grinding. Now, in this, for example, ultrasonic machining is a mechanical energy based process. What is ultrasonic machining? In this, the tool is vibrated at a high frequency known as greater than 16 or 17 kilohertz, we call ultrasonic, and between the workpiece and the tool a gap is maintained around 50 to 60 microns, and through the gap abrasive slurry is fed. Slurry consisting of abrasive grains and water is the carrier along with that, and the tool vibrates at high frequency. Due to the mechanical action of the grains hitting or striking the workpiece at very high velocities and on a narrow area, so very high stresses are developed and the material is removed by microchipping and erosion. This is the principle of ultrasonic machining. So, here to produce ultrasonics, we need an oscillator and a transducer. Oscillator will give you high frequency sine waves, and which the transducer converts this electrical energy into mechanical vibrations. And there is a tool cone known as horn connecting the transducer and the workpiece. And this tool cone is a particular shape, normally exponential, which gives maximum and advantageous resonance. So, the tool shape, because always a constant gap is maintained, the tool shape is reproduced on the workpiece. So, whatever may be the shape you want or product shape is previously machined on the tool. So, for example, dies, punches and dies. in wire drawing dies or stamping dies. So that shape is made on the tool and the shape is reproduced on the workpiece. The major advantage is, irrespective of its hardness, the material is machined. Particularly this process is suitable for brittle and hard material like glass, ceramics and titanium and other things. So these are some of the applications of USM. Similarly, abrasive jet machining, water jet machining, these are all processes. Like for example, in as I told you, electrothermal process, electric discharge machining. Electric discharge machining means the material is removed due to a series of sparks, large number of sparks of the order of 1 lakh or 2 lakh sparks per second, and this spark generates heat which will melt and evaporate the material.